When the polynomial p of x, which is equal to x cubed plus ax squared plus bx plus 3, is divided by x plus 1, the remainder is 1. And when p of x is divided by x minus 1, the remainder is 11. Find the values of a and b where this is true. So what we're going to do is we're going to use the factor remainder theorem, which says that if a polynomial is divided by x plus 1, evaluating it at p of negative 1, we'll find the remainder. So when we substitute in negative 1, we have negative 1 cubed plus a times negative 1 squared plus b times negative 1 plus 3, and that's going to be equal to 1. So that means that we have negative 1 plus a minus b plus 3 equals 1. And if we clean that up, we can find that a is equal to b subtract 1. And that's going to be the first equation that we're going to use in solving this question. Next up, if we have x minus 1 dividing the polynomial, putting in positive 1 is going to find the remainder. So we have 1 cubed plus a times 1 squared plus b times 1 plus 3, and this time that's going to equal 11. So we're going to have 1 plus a plus b plus 3 is equal to 11, and we can write that as a plus b is equal to 7, and that's going to be the second equation. So next up, all we're going to do is solve this simultaneously. So the first thing we're going to do is we're going to substitute equation 1 into equation 2. So for equation 2 we have a, which we can replace with b subtract 1, plus b equals 7. So that means we've got 2b minus 1 equals 7. So when we solve for b, we're going to find that b is equal to 4. Next up, we're going to substitute b is equal to 4 into one of the equations. So here we just choose whichever one's easiest, so we're going to use equation 1 this time, and that will give us the value of a is equal to b, which we found is 4 minus 1. So that means that a is equal to 3.